DM everyone, this is day 12 and we are continuing with building up our own decks, right? Yesterday I wrote two contracts for deploying our tokens, that is token X and token Y, and now I'm holding them into my wallet address, right? So I'll quickly show you up. I have token X and token Y in my wallet, right? Now what we are going to do, the goals for day 12 are we'll be writing the faucet contract, right? From where the users can actually claim token X and token Y, right? And we'll be deploying it to Sipula testnet, right? And yeah, and in the contract, we'll actually send 50,000 tokens of X and 50,000 tokens of Y into the faucet, right? But we can't just go here and click the send button and just send the token X and token Y onto our contract address. For this, we need to prove the transaction, right? If I am the owner of the token, I need to approve the transaction, right? Because ERC20 tokens cannot be directly sent to any contract, right? So for that, we need to approve that, and then we'll set up a simple React project for our front end for our decks, and we'll make a faucet component, right? So yeah, so let's just build a faucet contract first, right? So let's just go to our screen over here. I'll make a file called faucet. So token faucet. We'll name it as token faucet. Token faucet. So and license identifier and pragma solidity version 2.8. Right. Now what we need is an interface to use the bare minimum functions of IERC20. So I'll make an interface. Making an interface gives us the function to use for ERC20 tokens, right? So it's IERC20, then the function. We need the transfer function, which takes the parameter as address of to and the amount, right? For to where you want to transfer the wallet address and the balance actually, right? It shows you the balance. So we have the interface ready. Now what we need is to initialize the contract. Contract token faucet, right? And now what we need is the address to store owner of the address, right? We won't be doing this over here. We'll write that in constructor. The person who will deploy this will become the owner, so we'll write it in constructor. Then what I need is IERC 20 public token X, right? To store the address of token X, then IERC 20 public token Y, right? Now what I need is the amount which will be transferred to the user per claim, right? So it's u int, it will be u and 256 public amount per claim, right? Amount per claim that will be equal to let's say 100 into 1 is 18 decimals. So that is 100 tokens. And should we give the claim interval? Uh, yeah, let's just give it event cooldown 256 public. I'm just mentioning it over here, but I'll keep this value as 0. Otherwise, it will cause we won't be able to if I 1, 2, 3. So here I have made the claim interval as, or I'll change the name and do it as cooldown. I'll change the name as cooldown, but I'll actually keep it as 0 because we need to test it, right? We need to claim again and again. So why will I wait for 1 hour, right? Now we need a mapping to store the claim times of the user, right? And for claim time of A, and we need a mapping for claim time of it will be X and it will be Y. The token name are X and Y. So yeah. Okay. Now what we need is a constructor. Constructor. There will be two arguments of two token address token X and token Y. Yeah, address correct. Okay. Now what we need is actually writing a function to claim token X. So function claim token X, right? And it can be called externally, external, and it gives me correct suggestion. What it is doing, it is checking that the timestamp of the block is greater than or equal to the last claim time, which is being stored in this, right? And plus cooldown, we should not write it over here, but it's okay. It's 0. If it is less than it, then it will return this message, right? Then, and what it is saying, it says that our contract should have the balance greater than the amount, which the amount per claim, that is 100. So the balance of our contract should always be greater than 100, right? And then it transfers token X to from the message dot center, right? So this is it, and now we will make a function called claim Y, right? And make this Y over here. This is Y. Last time claim Y. Okay. Here it's token Y. Yeah, so this is the function to claim token Y. Now we need a function by which the owner of this contract can actually set the amount per claim. So let's set amount per claim, right? And what is it saying? It requires that this function is only be called using message.sender equals to owner, right? And then the amount per claim is being set it to this amount, which is being passed in the argument, right? And then what we need is set cooldown function similar to this. What happened? Okay. And then we need a function called set cooldown. So this will set the cooldown period. Now it is actually 0, but if in future we want to set it, we can actually do it, right? And then we need a function to withdraw the tokens. The owner of the tokens can actually come here and withdraw it, right? So yeah, this is pretty much it for, and we need one more function to get balance, open x dot balance, and we need a function to get balance token y, right? So yeah, this is our faucet contract. Okay, now let's just deploy it using deploy script. So I write over here faucet deploy .js. Okay. Now what I need is I'll use ChatGPT and actually get the deploy script from here, right? So yeah, give me deploy script. I am using Hardhat as framework, and I want it to be deployed to Sepolia. Yeah, so it is giving me, we need to paste our tokens contract address over here, right? And yeah, this is pretty much it. Okay, we'll go to our file, paste it up over here, just replace it with our token addresses. So let's go to Etherscan. I This is my wallet address, and I have created token Y over here. This is the contract address of token Y. Let's just paste it up over here. After that, I will be storing this into this environment variable, right? But for now, I'll just hard code it up. Now, it's just contract creation, a contract address of token Y. Sorry, it is the token address of token X, right? So this should be this should come over here, and token X should go here. Okay, so this is done. Over here, we will use wait for deployment and faucet. Right, now let's just run the script. So npx hardhat run dot slash script faucet network is Sepolia. Yeah, so it is deploying. Let's just wait for some time. Okay, so yeah, our faucet is being deployed. Let's just check it on Etherscan. Control R. It is not actually showing up over here. Let's just wait. Yeah. So we got our faucet contract over here, right? This is the contract address of our faucet, right? Now what we need is to actually approve the transaction and send 50,000 tokens to this contract address, right? So let's just make faucet claim server.js, right? Let's just go to ChatGPT and get a file. Hmm, I need to approve and send token X and token Y to the contract address. Give me a script for it, and I will just paste the contract address over here. Yeah, okay, this is it. Yeah, okay, so I got that. I'll paste it over here. Was it transfer? V. Now I need my token X address and then move it to environment variable, right? But just for the time, I'm hard coding it up over here, right? And the faucet's contract address we get from scan, copy, and yeah, it is over here, right? Okay, so yeah, this won't be utils. Okay, okay, okay. We need to uh, 50,000 tokens. Uh, yeah, now this should work. Now let's just run this script slash offset transfer network. Yeah, so it is transferring what happened. So yeah, over here we got 50,000 token X and 50,000 token Y, right? We got some error over here, but our task is done, transferring token X and token Y. Now we don't need this flip, so I'll keep this error as it is, right? Now what we need is to create a front end for this, right? So I have a React project set it up over here with Tailwind. Now what I need is to build a component, right? So I'll make a component as faucet.jsx, right? And just go to ChatGPT and just tell it to see, make a nice front end for me from where the user can connect the wallet and claim X and token Y. So it is generating code for me. Till then, what we have our router file over here in app.jsx. I'm using React Router DOM. I have everything set it up just to save the time in the video, right? Let's just make this component and we'll just import it over here, right? Let's just comment this line out. What is it generating? Wait, I need to mention that I'm using Tailwind and I need it in GSX. I am using Tailwind. I want it in GSX. Okay, so it has generated code for me. Now what I need is to paste it up here simply, right? And yeah, it has my token address. It should be replaced with this. It has, okay, it is replaced with the faucet address. Let me check that I copied it correctly. Okay, I copied it correctly. Okay, no. Is it correct? Let me just check. Oh, wait, just a second. Yeah. Hmm. Okay. Now I need this. Put it in this. Import um, dot slash components slash faucet. Right? Okay. Now run this project. And yeah, my my wallet is being connected already. It's just disconnected. Okay. Now, if I click this connect wallet button, it detects MetaMask in my browser. Then I can actually connect it. Now it's connected. Now I can claim token X from here. I'll confirm the transaction. It will take some time and it will transfer this to our wallet. Yeah, so it has transferred, I think. Okay, let's just go to tokens. Yeah, so see, the balance is being updated. So I got token X and token Y into my wallet, right? So yeah, this was pretty much it for today. I'll see you guys tomorrow.